Welcome to the next part of our Firetail tutorial on advanced acceleration annotation Firetail 8. My name is Tobias, I'm a software engineer and a data scientist at Crofoot Berger. So what will you see in this tutorial? Part 1 will be concerned with the advanced model training that's possible in Firetail 8, and part 2 we will work through a real-world example. So the problem setting is still the same that you are used to. You get the tags on your birds and animals. You get acceleration data and you want to make sense of it in terms of behavior. What is the behavior that is assigned to each pattern that we observe in the acceleration data? And you want to integrate the complete context of your data. You want to integrate all the sensors, you want to integrate all the measurements that you got. We can then use the FireSOM prediction, the Firetail acceleration segmentation algorithm, to get an initial draft of the annotation, for example rest flight or specific flight behaviors, specific types of flight. There are a couple of refinements that I talked about last time. For example, merging of lanes is possible to just join categories, and a new one is available in Firetail 8, which is subdivision. You can select a complete layer. For example, in this case, we choose the layer rest and do a second round of FireSOM on only this selection. And we will arrive with a parameterized model on the one hand, and on the other hand, we get the complete prediction for the selected regions that we selected previously. And we also can, and this is new, predict other individuals and other animals, other tags via a previously parameterized model, stick it into FireSOM and get a prediction for this new tag, new animal, whatsoever you want to do. And you see here you have the type A and type B of the specific annotation. So what's the deal with the cyclic annotation refinement? So we want to show you a way to iteratively refine your predictions. You get an initial annotation. You can, like usual, merge, delete categories, assign new layers, link categories and their behavior. And then you can, as I showed you previously, do a manual selection or do the selection via annotation layer. So you select a complete layer of annotation and run FireSOM again and arrive with a refined annotation, and you can repeat this process until you're satisfied with the overall result. So now let's dive into the part 2 of this tutorial. I'll keep this a bit shorter than usual, you see. The real-world example. So we get to the a bit revised overview here. Get our user manual when you start up Firetail, the newsletter, the Firetail Viz Twitter account, and also look into our Reddit account, by the way. That's new, Firetail Viz, the subreddit. And we'll start with a dataset by Crofoot et al. And I previously loaded a white baboon study dataset that's freely available from the MoveBank data repository. Let's skip the loading for now. And first thing you do, obviously, is you want to get familiar with the data, which Firetail is obviously perfect for. You can zoom into all regions. You see these orange dots above. You see where there's a GPS coverage in the dataset for the acceleration bursts. You can switch to the Bing aerial view to get a better idea of the location that we're looking at. When you're interested in traffic, obviously you would use the OpenStreetMap view that is totally revised for the new Firetail edition, Firetail 8. Now let's leave the baboon running here a bit. We can press follow. For many individuals, we did a lot of speed up with the follow routine. And you see the firetails here on the map when doing the replay. Now let's dive into the data details. So we have 1.5 million acceleration bursts and 1.5 million GPS fixes in this data set, and now we want to use this data to do a segmentation of the acceleration data and make sense of the patterns that we observe here. For a start, we don't want to restrict to a selection or save the model, and we will stick with the default parameters and simply run the model training. First step of the complete model training in FireSOM is that the features that you have selected are extracted from the raw data. For this 1.5, is it 1.5 million? It's pretty much possible to wait for this. You don't need a web service or internet connection for this. You can do this offline if you choose to. And now we see we have one pretty large category, or several categories. We have categories 0, 0 to 2, 2 that basically correspond to the coordinates in the self-organizing map and the resulting self-organizing map. And, well, we may be not too content with this category 2, 2, because you see the most striking features are covered, but frankly, category 2, 2 is much too large. So let's do annotations via selection, and we select the complete lane that covers the category 2, 2. And if you see into this, we see that all other categories that are not part of this layer are excluded. And we can now do something that was not possible before. We can now restrict to this selection and only run the model on this very category. And all the bursts that are inside there, inside the selection, will be used for our L2 model. Let's name this L2. And press OK. Features are extracted again, normalized, and then the training of the self-organizing map takes place. And the final step is, of course, the assignment of each burst to the specific category. And you see we get another set of layers here, L2, that contain the more detailed subdivisions for this 2-2 layer. And this is, of course, much more fine-grained, much more into detail of what is actually happening within these acceleration data. And in combination with the previously predicted annotations of the initial step, we also get the peaks that are basically detected first, the peak data, and the lower level, so to say, predictions with the L2 model that we have. So as we see, we could now delete the original 2,2 layer, because basically all the information would also be contained within the L2 model and within the L2 prediction. And well, let's see into this result a bit. So for example, here we see a big tree or set of trees, and when we click here, we see some enrichment of a specific category and some movement there. So within the tree, there's a bit of movement going on. Maybe under the tree, we don't see it specifically. The height is not suggestive in this direction because we cannot determine whether we're on a tree or below a tree. But here you see, for example, the 1-2 and the 2-0 layers seem to indicate a bit of movement. So what we can do is we simply remember the category that we have there, and we edit this category and assign it to a new layer name that we, for simplicity here, just name strong. And then just name it, not A1, let's say S1 for strong 1. And yeah, you see then the new category, the new layer is in place, and the first category is a member of this layer. We do the editing again, and this time we also choose the strong, one more time, the strong layer, and assign the S2, like strong 2. So this is the common way that you are used to editing annotations in Firetail already. So in this case we have we can approach the final model by merging, reapplying, and reselection, which is pretty neat actually, pretty neat workflow for giving you good annotation. So let's load another dataset from Case et al. 2011. We load one individual there. And I want to show you how to train models using specific selections. Well, I select two regions here, and by pressing Shift Control left click, I can select another region, which obviously has specific patterns in there. And I want to restrict my model training to this selection that I just did. And I want to save the model for later application. Let's keep it simple. We only use the continuity feature with us, which is a bit similar to the overall dynamic body acceleration, but basically counts the deltas between each timestamp and accumulates them. So let's choose a model name A and do the training. And you see the prediction is only done for the selections, but the underlying model is obviously not limited to predicting certain regions. We can use the model that we did to predict the complete animal as well. So we can go to the FireSOM application again. We can use the model A, and you see that all the parameters are grayed out, and then we have a complete prediction for the complete animal. And now I want to show you how to do a full-scale model. We open another individual from the same data. Let's see, yeah, toucan, and this is the other individual. The data is somehow similar, but may not be completely equal or identical in terms of the distribution. So let's see what happens when we actually apply this model A that we previously trained on this individual. Let's use the same settings. And what we see is that the basic characteristics are patterned, and in this way you can apply one individual model to another individual's model. So now let's do a full-scale model, because last time we did this on selection, when you remember. We only trained the model on a very limited set from the original data. Now we want to save a full-scale model that is trained on one complete individual, and we want to predict another. So in this case you see that the resolution is much better here, and we can really capture much finer characteristics with this specific model. So let's see into the other data set. It's the first one that we had previously. We do the FireSOM segmentation again. We load our trained model, load the full-scale model, press OK, and we see this full-scale model has been applied to the first individual. And this time it's much better on the initial shot, and now we can do the usual refinement and work towards our final model. Thanks for watching.